Hi students, welcome back to our channel Smarter Everyday Over Learning. Dear students, what we have been learning from the chapter Organic Chemistry, some basic principles and techniques from grade 11 NCERT. Previously in our session we discussed about just by seeing the compound molecular formula how we can give the name, particular name basing upon the IUPAC nomenclature, the rules, everything we have studied. Okay, now in this session completely it is the reverse process basing upon IUPAC name of the organic compound if its structure is given. For suppose here if you see the structure, basing upon this structure how we can derive the name, IUPAC name of this particular chemical compound we studied in our previous session. Now in this class, what are the steps we have to follow while writing the structural formulae from the IUPAC name of the organic compound? Here these are the steps, 6 steps you have to follow. These 6 steps one by one I'll explain to you. And in previous class, rules for naming alicyclic compound just by seeing the chemical compound, the chemical formula like this, the chemical formula, how we can derive the IUPAC name, everything completed. Okay, once you can check the description, I'll provide for you all the links in the description. Right, let's start our today's session. Here the first rule is, select the longest carbon chain from the word root. Word root, nothing but the longest carbon chain from the principal chain, from the word root of the IUPAC name of the organic compound. For suppose we studied previously, for the root word is pro, that connect 3 carbon atoms. The connection of 3 carbon atoms, the root word is prop, we studied previously. And for the word bute, there is a connection of 4 carbon atoms. Okay, for the root word is pent, there is a connection of 5 carbon atoms. Okay, and so on by a single bonds in a straight chain. If for suppose all the single bonds are presented in a straight chain, that belongs to alkane group, that is a saturated hydrocarbon that we studied previous class. Okay students, that is the first rule, select the longest carbon chain from the word root of the IUPAC name of the organic compound. Okay, let's go for the second one. Second rule, writing the structural formulae while by basing upon the IUPAC name of the compound. Here second one is number of carbon chain from either direction. That means here for suppose like this, in which way we have to give numbering to these particular compounds, particular carbon atoms, you have to study in this second rule. And coming to third one, third rule, what I have written here, then identify the primary suffix here. Primary suffix, that is ane, ene and ine. Okay, belongs to alkane group and alkene and alkyne group. From the name of the organic compound, if the compound contain a double bond or a triple bond, identify its position from the name of the organic compound and put the double bond or triple bond as its right position along the carbon chain. Like this, along the carbon chain you need to identify the primary suffix. What is the primary suffix? Right. And rule number 4, identify the name and position of the functional group here. Functional group, that is secondary suffix from the IUPAC name of the compound and that fix at its right position on the carbon chain. Okay, you have to identify the name, exact name and the position of the functional group, that is only secondary suffix. In rule 4, you need to identify the name and position of the functional group, that is secondary suffix. But in the rule 5, you need to identify name and the position of the other substituent, if any from IUPAC name, and fix them at the correct position. Okay, that is about rule number 5. And finally, rule number 6 is, finally, wherever necessary, attach the required number of hydrogen atoms to satisfy the tetravalency. Tetravalency means you know that carbon has a valency 4 and it needs to form 4 bonds with the other atoms. That thing you know very well. Basing upon the tetravalency, you need to attach the required number of hydrogen atoms. Right, these are the rules while we are writing the structural formulae from the IUPAC name of the compound. Let's see the examples of this. Basing upon all of these rules, you need to give the particular structure, exact structure basing upon these rules. Let's see the first one. Derive the structure of, see here, pent 4-ene 2-ol. Okay. Here, basing upon step 1, select the longest carbon chain from the word root. Word root means, in this example, word root we have, that is pent. So, step 1, the word root pent indicates that longest carbon chain contains 5 carbon atoms. Then students, you need to write like this, 3, 4 and 5. Okay. Now, step 2. Step 2, number of carbon chain from other direction. Number of carbon chain from the direction you need to identify here. Then to these carbons only you need to give numbering 1, 2, 3, 4, 5 like this. And step 3. In step 3 you need to identify the primary suffix here, that is whether it belongs to alkane group or alkene or alkyne group. Then students, if you see the example here 4-ene is there, 4-ene, so that belongs to alkene group. You need to identify that. So in step 3, one alkene group is presented, you need to identify that. Okay, alkene. And step 4, identify the name and position of the functional group, that is secondary suffix, functional group. So here the functional group is 2-ol indicated. Ol means nothing but alcoholic group. So in step 4, what you have to do, the primary suffix ene and the numerical prefix here 4. They have given here 4 before the suggested that there is a double bond at the position of 4. Therefore, put a double bond between the position of 4 and 5 as shown like this. 3, 4, here one double bond, and all alcoholic group must be here at the second carbon. 3, 4 and 5. Here the second 2-ol means at the second carbon alcoholic group is located. 4-ene means at this fourth carbon double bond is located like this. And coming to step 5, what you have to do, step 5, here the substituents already completed about OH alcoholic group, that is completed. And finally, wherever necessary, attach the required hydrogen atoms to satisfy tetravalency. Tetravalency means here in this compound satisfy the tetravalency of each carbon with the required number of hydrogen atoms. Thus the structural formula of this pent 4-ene 2-ol should be here CH3, CH, CH2, CH, here double bond, CH2. Then at the second carbon OH group is located. 3, 4 and 5. The name of the compound is pent 4-ene 2-ol. Pent means there must be 5 carbon atoms here, 1, 2, 3, 4, 5. And second, at this second carbon OH group is located. And the same structure, if I draw like this, here students you can see carbon CH3. First one is CH3, so CH3 like this, and second is CHOH. Here CH, here is the OH, and here CH2 means 2 hydrogens here, and again here CH, only one H. Now double bond, here double bond same, CH2. So these two are same. Okay, pent 4-ene 2-ol. These two structures are same. Let's see the next example. Give the structure of a compound 3-nitrocyclohexane. Here, basing upon this name, you need to identify that is a cyclo compound. So here step 1, what you have to do, primary prefix here the word cyclo, and hexane, this is the word root hex. Then ane is the alkane group, you know that. And step 1, the primary prefix cyclo and the word root hex means the given compound contains a 6-numbered ring, not a chain. So ringed compound. Therefore draw a cyclohexane ring. just like this. Cyclohexane means just like this, benzene ring without bonds. And step 2, number the carbon atoms of cyclohexane ring as indicated. For suppose this is the compound example, just numbering these carbons 5 and 6. And step 3, the primary suffix "-ene" without any numerical prefix indicates that there is a double bond at position 1. Therefore, put a double bond between the position of 1 and 2. Then the structure should be double bond placed in between 1 and 2 carbons. Then step 4, what you have to do, the secondary prefix. The secondary prefix here, nitro. Nitro they have given secondary prefix. What is that? Nitro. Okay students, this nitro. And the numerical prefix. Numerical prefix is here 3. They have given in the question itself 3. Before it suggests that here is a nitro group. Here is a nitro group at the position 3. Therefore, a nitro group at the position 3 means the structure should be here, the numbering same. Here is the double bond itself, and at the third carbon a nitro group is located. So this represents the complete structure of 3-nitrocyclohexane. 3-nitrocyclohexane. Here cyclo is the primary prefix, nitro is secondary prefix. Here 3 is the numerical prefix. Numerical prefix, here hex is the word root, nothing but root word, and this is the suffix of whether it is alkane or alkene, just like that, suffix, primary suffix. So the final structure should be like this, 3-nitrocyclohexane. Okay, let us know about third example here, 2-chlorohexane, the name, and for this you need to draw a structure. And here students, this is 2, number 2 is the numerical prefix here. Numerical prefix, you need to identify everything. So here chloro is the word secondary prefix, and hex is the root word you know, and this is also belongs to alkane group, so alkane, that is the primary suffix. Okay, and here is hex, the word hex, that means how many carbon atoms you need to draw students? Hex means 6. Okay, 3, 4, 5 and 6 carbon atoms. And 2-chloro at the second carbon, this second carbon chloro, one chlorine is attached here. Here is a halogen group. Okay, and the name should be alkane, that means all the single bonds only presented here. You should add at the required positions the hydrogen atoms. Let's see here, hydrogen atoms means this structure should be CH3, C here must be Cl and CH, CHCl and CH2, 1, 2, 3, 4, 5 and another one here CH3. So this is the compound, name is 2-chlorohexane. Here see 6 carbons located, then hexane. Right, let's see the fourth example, 6-hydroxyheptanol. Here one hydroxyl group is located, and students, one Al means nothing but aldehyde group. Aldehyde group also located here. Right, and 6-hydroxy means here you need to identify the word root first of all. This is the word root hept. Hept means nothing but 7 carbons. 7 carbons including that group CHO, that is aldehyde group. Okay, here at the second carbon hydroxyl group is located. While giving numbering to these carbon atoms, here you have to give first priority to this aldehyde group and second 3, 4, 5, 6, 7. At the 6th carbon hydroxyl group is located. Why? Because basing upon this name 6-hydroxy. Okay, and the same structure, if I draw like this, here CH3 you need to add all the hydrogen atoms at the required positions. CH3, CHOH, CH2, 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 CHO. CHO numbering should be like this, 6, 7. See here, 7 carbon atoms are presented here. Then 6 hydroxy heptanol, 6 hydroxy, 6 hydroxy. This is the hydroxyl group, and hept is the root word, and here is the aldehyde group, CHO. Then the suffix should be AL. Okay, right. We have fifth example here, hex 3-ene 1-oic acid. So by seeing this name of the compound ene, so it belongs to alkene group. You need to identify that. Here is the hex is root word. Hex means 6 carbons. Here 6 carbons including this oic acid. Oic acid means nothing but COOH carboxylic group. 4, 5, 6, sixth carbon only, that is carboxylic acid. Okay, and to this 3-ene. 3-ene means 1, 2, 3. To this third carbon there is a double bond. Then the structure I am going to draw here, CH3, CH2, here CH, double bond, CH, CH2, COOH. COOH is the oic acid here, and if I give numbering to this carbon, 1, 2, 3. At the third carbon, double bond is located, so 3-ene. And the same structure if I draw, first one CH3, so 3 hydrogens like this, and second one is CH2, 2 hydrogens, and now here double bond is presented, so CH, double bond, CH, here also CH, single bond, here CH2, again CH2, 2 hydrogens are there, and for COOH you need to draw like this, C double bond O and OH. Numbering here 2, 3, 4, 5, 6th carbon, and here at the third carbon double bond is located. Okay. In this next example, 1-bromo 3-chloro-cyclohex-1-ene. So it is a cyclo compound, you need to identify. So hex is the root word, then you should draw like this, hexane. Then 1-bromo, that means at this first carbon you should take bromo. Here is 1, 2, 3, 4, 5, 6. Okay, and 3-chloro. 3-chloro means nothing but at the third carbon you need to add chlorine. Here is bromine. And cyclohex 1-ene. 1-ene means at the first carbon only double bond is located. So 1-bromo 3-chloro cyclohex 1-ene. This belongs to alkene group only, so this is the structure. In this next example, 1,3-dimethyl cyclohex 1-ene. Okay, here 1,3-dimethyl, 2 methyl groups are located, and this is also a cyclo compound, and hex is the root word. Hex is the root word means you should write the chemical formula. Structure will be like this, hexane. Okay, and here hexene, one double bond should be located here. Then 1,3-dimethyl means if you take the numbering from here, starting from here, 3, 4, 5, 6, and here is one methyl group, and here also one methyl group. At the first carbon only double bond is located, and the structure should be here 1 CH3, and at the third carbon 1 CH3, that means methyl group. At the first carbon only one double bond is located. So this is the structure for 1,3-dimethyl cyclohex 1-ene. Okay students, this is about today's session. What are the steps you need to follow, you need to keep in your mind while writing the structural formulae from the IUPAC name, basing upon the IUPAC name of the organic compound. Here 6 rules I have explained to you. Basing upon these 6 rules, some examples also we have done in this class. Okay students, your opinion completely, your doubts also you can convey in the comment section. Please, if you like this video, if you understand, please subscribe to my channel for my further updates. In our previous session, rules for naming alicyclic compounds is completed. In our next class, next session, nomenclature of simple aromatic compounds. About that topic I'll explain to you. Okay, keep watching. Thanks for watching. Have a nice day.